Good day everyone, I'm Shariza Albiharan from grade 12 Mendel, and today I'll be discussing an important topic in physics. Have you ever noticed a book stays perfectly still on a table? Or how a person can stand without falling? Or how a seesaw can stay balanced? All of these are great examples of static equilibrium in action. Our lesson for today is determine whether a system is in static equilibrium or not. Let's start by understanding what static equilibrium means. The word static refers to the body being at rest, and the word equilibrium refers to the state where all opposing forces cancel out each other and the net force on the object becomes zero. It refers to the physical state of an object when it is at rest and no external force or torque is applied to it. When all the forces that act upon an object are balanced, then the object is said to be on static equilibrium. So, static equilibrium happens when an object is at rest and all the forces and torques acting on it are balanced. In simple terms, the object doesn't move and it doesn't rotate. It just stays still. Let's look at some examples to understand better. Number 1. A book on a table. The downward pull of gravity is balanced by the upward push of the table. Number 2. The stationary person. The ground pushes up with a force equal to the person's weight, keeping them still. Number 3. A balanced seesaw. The weights on both sides are equal, and the torques cancel out, keeping it level. In each of these examples, there is no unbalanced force and no rotation, so the system is in static equilibrium. Conditions for static equilibrium. These conditions make sure that the object is not experiencing any linear or angular acceleration, meaning it is at rest or moving with a constant velocity. Translational equilibrium. Let's talk first about translational equilibrium. A body is in translational equilibrium if there is no net force acting on it, so it does not move in a straight line. A body is in translational equilibrium when the net force acting on it is zero. This simply means that the total forces in the x, y, and z directions cancel out. For example, when a book rests on a table, the downward force of gravity is exactly balanced by the upward normal force of the table. That's transitional equilibrium. Next is rotational equilibrium. A body is in rotational equilibrium if the clockwise torques is equal to counterclockwise torques, preventing rotation. A body is in rotational equilibrium when the sum of all torques or moments acting on it is zero. A body is in rotational equilibrium when the sum or torques or moments acting on it is equal to zero. For instance, if a seesaw has equal weights on both sides at equal distances from the center, the torques balance each other and the seesaw stays level. That's rotational equilibrium. Steps to determine static equilibrium. Now, let's learn the steps to determine whether a system is in static equilibrium. Step 1. Identify forces and pivot points. Draw a free body diagram showing all the external forces acting on the object, and mark the pivot point or axis of rotation. Step 2. Check transitional equilibrium. Add up all the horizontal forces and all the vertical forces. If both are zero, there is no linear movement. Step 3. Check rotational equilibrium. Choose a pivot point and sum all the torques about that point. If zero, there is no rotation. Step 4. Evaluate. If both the net force and the net torque are zero, the object is in static equilibrium and will stay at rest. But if either of the conditions is not met, the object is not in equilibrium. It will move or rotate.